All right, now we're going to talk about conductivity. So this is a continuation of the properties of solutions. Conductivity. We'll go black, conductivity. So conductivity deals with how electricity can move through the solution. So it is a homogeneous solution, but some homogeneous solutions are conductive, meaning they can have electricity run through them, and some are not. And it deals with another word that starts with the same prefix as electricity. It's called electrolytes. We're going to write 3 types of electrolytes. Three types of electrolytes. There are non-electrolytes. Let's do a different color. Got non-electrolytes. We've got weak. We've got strong electrolytes. So under non-electrolytes, these are things that, and I'm going to use a new word here, these are things that do not dissociate. Do not it's almost like it's saying disassociate. To associate with somebody is to be friends with them, to get to know them. This is dissociate, the opposite. So it's D-I-S-S. Well, you can think of it as dissing somebody. Dissociates. Dissociates. It does not dissociate. They do not dissociate in water. They do not dissociate in water. So example is sugar, or C6H12O6. So this does not conduct. Non-electrolytes do not conduct. So electricity cannot move through them. We'll draw a little thing down here at the bottom, a little beaker with some liquid in it. We're going to have plus and minus stuck together. Plus and minus stuck together. I think this will make more sense visually when we get to the next one, especially the last one. So weak electrolytes, they kind of disassociate. We'll say some dissociate in water. Some of them. So non-electrolytes do not dissociate in water. Weak electrolytes, some do dissociate in water. An example of this, switch back to brown. An example of this would be water and vinegar, H2O plus vinegar vinegar. These are poor conductors. So in the vinegar, it is, so what we've been dealing with so far in most of our class is NaCl or something similar, but vinegar is a more complex molecule. It actually is made of, I don't think we're going to go into that, but it's made of several elements, and some of those elements break apart and some of them do not. So because some of them break apart, I'll show that down here. I'll show you what I mean. So some of them break apart. So you may have, to keep it simple, we'll say plus and minus. So that's the parts that don't conduct. But then some places you've got these little ions. I believe they can be both positive or negative. but you've got these ones that are all by themselves. And electricity really likes to jump between these ones that are separated. It's easier for electricity to flow through them. So now let's get to strong electrolytes. Strong electrolytes fully dissociate in water. So they completely come apart. A great example of this is table salt. NaCl is table salt, if you don't remember. And these are great conductors. So all three of these examples that we've given are solutions. All of them are solutions. All of them dissolve in water, or the solvent that they have. In this case, these are electrolytes in water. But some of them dissociate, don't dissociate at all. Some of them somewhat dissociate. Those are weak electrolytes, and strong electrolytes are examples like sodium chloride, NaCl. So you'd have a bunch of pluses and a bunch of minuses. And what happens is the way that I understand it, electricity can jump between these pluses and minuses very easy to go from one side. If there's electricity, like you'll see today, it can jump through all of these. Do this in black. It can jump through this easily because it's going through all these ions, cations and anions. So this would be an example over here on the right side. That would be an example of a very strong electrolyte. And as a reminder, dissociate equals dissolve. A better, than say that, let's say it splits apart. So if you stop associating with your boyfriend or girlfriend, probably means you broke up. You're on a break. So this is the stuff that makes what solutions conductive or not. Again, all of these are solutions. Some of these solutions are not conductive at all. Some of them are somewhat conductive and some non-conductive. So electricity can find its way through, but it's not very quick. It's not very effective or efficient. Strong electrolytes like like salt are very good conductors. And so if you were trying to make electricity go through water, you would want a lot of salt in it because the electricity can go through that very, very easily.